Next, coming to the nomenclature. Nomenclature is nothing but we will generally weld any component, right? So this is the weld portion. So generally this is called as a weldment or a weld bead, right? So this weld bead will have a typical nomenclature, that means the parts of a different portions, right? So what are the different nomenclatures of a weldment or a weld bead? So generally we will have a base material. So this base material is where we are going to weld. And the next one is electrode, right? So electrode will have a flux and the electrode metal, which is encapsulated. We will have a electrode. When we are trying to cut this electrode in a cross section, we can able to see like this, right? So generally we will have a electrode metal. So this electrode metal will melt. So this electrode metal was covered to the flux, which is always be a shield for the environment. And the next one is gas shield. So it is a fume over the welding process. This generally this gas shield is used to protect this welding from the environmental gas, because our environment is having some mixture of gas like oxygen, right? When the oxygen reacts on this welding, there will be some formation of a different alloying elements, right? So to protect that, we will have some gas shield, and also we will have a slag. So this is nothing but a slag, and this is the penetration. So that means the depth of a welding is nothing but a penetration, and this is the weld bead, right? So this is the weld direction, and this is the formation of a welding is nothing but a weld. So this is a nomenclature of a weldment. If we are trying to groove type of a welding, so this will be the nomenclature. So these are the two different base materials, right? This is the edge of this base material, and the blue color is nothing but the welding portion, right? You can able to see the different nomenclatures. So it's supposed to be complete here, but the welding has goes like this. So that portion is called as overlap. That means the undesirable weldment, and the top portion is called as a face of a weld, and the portion which is from the base material to the upper face is nothing but the face reinforcement, and the starting of this portion weld, that means, so this is the weld means, and this portions is nothing but a toe of a welding. That means the starting point or the foot of a welding, and this is the root reinforcements, right? It's supposed to be stopped here, but it is extended like this. So this is nothing but the root reinforcement, and this is the root opening, right? So these are the different groove type of a welding nomenclature. The same we are having a fillet type of a welding nomenclatures, right? So the thing is the same. The depth of a welding is nothing but the penetration, how much it is going inside the raw material. That means the base material is nothing but a penetration, and the starting point is a throat, and this is the face of the welding, and the starting point is the throat of a welding, and the total portion is a leg size. So generally in welding we will have two different types. One is a groove type or a fillet type. And coming back to the welding position, so as I said before, we are having four different weld joints. So one is flat type, horizontal, vertical, and overhead, right? So also we are having two different weld joints, nothing but the flat type of a fillet type of a weld joints, or the groove type of a weld joints. So putting this together for a different application, we will have a weld position, right? So first we shall see on the plate, that means a flat surface, right? So the weld positions will be denoted in a alphanumeric. That means in the alphabet we will use either F or G. So F stands for a fillet type of a welding, and G stands for the groove type of a welding, right? And this numeric 1, 2, 3, 4 is nothing but the flat, horizontal, vertical, and overhead. You can able to see the different types of a welding position. So this is typically for the plate, right? If you are having a groove welding in the horizontal position, we will use 1G. Okay. So if you are going to weld in the horizontal type, right? But it is a groove type, so we will call as a 2G position, and same as welding 3G, and the overhead position is 4G. So this is the difficulty process, right? So always this 4G is very difficult to weld. When come for the fillet welding, we will use 1F. If it is mentioned as a 1F, then it means that the fillet type of a welding in the flat manner we have to weld. If it is 2F, it is a horizontal type of a welding, and 3F it is a vertical type fillet welding, and 4F is nothing but a overhead fillet type of a welding, right? Where comes to the pipe, so generally welding the pipe is very difficult and a very tedious process. So generally the high skilled labor will be deployed in welding the pipes. So the thing is same in the pipe welding, we don't have a fillet kind of a welding, only groove type of a welding will be there, so that we will mention only G. Whereas the numers will be changed, so we will have 1 2. Okay, if you are using 1 means it is a horizontally rolled one. If we are using 2 means it's a vertical type, and if we are using 5 means it is horizontally fixed, and if you are using 6 means the pipe is inclined about 45 degree, right? So you can able to see this is the first type of a welding, that means 1G. 1 represents horizontally rolled, and G is nothing but the groove type of a welding. So welding is flat and pipe is rotated and in the axis of a horizontal. If you are using the 2G, it is nothing but we are trying to roll the material, roll the pipe in the vertical manner. If we are using 5G, it is nothing but the horizontally fixed. We are not going to roll the pipe. We are going to fixed, but the welding is vertically upward. So how we will do means we will try to weld like this. Okay, so the welding will be like this. So we will start from this point and we will complete this one. Whereas if it is 5G, PG, 5G means, so it is nothing but the vertical downward, so it will be a reverse position like this. Okay, so if you are using the 6G, it's nothing but the thing is tilted to 45 degrees Celsius, sorry, 45 degree. So the welding will be upward, that means it will start here and it will end here. So if it is J elbow means, so it is directly opposite to this position, so that means it starts here and, sorry, it starts here and wells here. So these are the different well positions. So generally we will have either a pipe application or the plate application. So it will be used like this. So these are the different welding positions. Sir, where this welding positions and weld this 1G 2G will be all mentioned means, so generally you will have a work welding specification sheet. So that means we will have the engineering drawing. No, so once we are seeing that engineering drawing, we will came to know about the component. In that engineering drawing, they will put all these things. That means what we have seen, the positions, and the very important thing is weld symbols, right? So they will represent this welding as a symbols in the instruction sheet, that is nothing but the engineering drawing sheet. So as I said before, we are having only two types of welding. One is groove welding and another one is fillet welding, right? And we are going to do this two type of welding in a different position, whether it may be a flat, horizontal, vertical, or overhead, right? And also we are going to do in a different joints. Okay, so this all the things will be put in together in a engineering drawing sheet. So by reading that engineering drawing, we will came to know about how we want to do the welding in the final component, right? So this is an engineering language, right? So this is to be communicate between the design engineer to the manufacturing, that means the weld engineer. So how the welding process has to be done and where to be welded and how much to be welded. So to communicate with the manufacturing engineer, that means the weld engineer, the symbols is very, very important. You can able to see if it is a groove type of a welding, so you can able to have a square type, scarf, V, bevel. There are different types of a groove type welding, right? So this each type of a groove welding have a different symbols, right? You supposed to be remember all the symbols, okay? Bevel, and same as fillet, you can able to see these are the different fillet symbols. So this will be put into the weld symbols in the engineering drawing. So this will be put in the welding symbols. So this is the weld symbol, and welding symbol all put together is nothing but the welding symbol. So this is the nomenclature of a welding symbol. I will explain very detailedly about this. So always it will have one horizontal line. So this is generally called as a reference line. All the welding symbol will have this reference line. And the next one is arrow line. So this will be like this. And this is also a necessary kind of a line. And the next is tile. So in this tile, they will have some additional information like what type of a welding, that means you are going to use arc welding or something you are going to use. And next comes this triangle. So if it is a triangle, it is nothing but a fillet kind of a building. Okay. If it is square, sorry, if it is it's kind of a like this square means you have to refer, okay, it is a plug or slot. Or if it is kind of a like this means you can able to see this is the bevel. Okay. So generally they will put on the above side or the below side. I will explain in the upcoming slide. And the next one is you will have some numerical values in the right hand side and the left hand side. If it is in the left hand side, it is nothing but the size of the welding. If it is on the right hand side, the first set of numerical value represent the length of the welding. Okay, the size of the welding means how much the weld bead should be. Okay, so this is the welding, how much the weld bead should be. Okay, that means the next one is the length. Okay, so this is x and this is y, and the next one is pitch. Okay, how much this should be. Okay, so this is the different numerical values which will be represents in the weld symbol, right and left to the weld symbol. And this is the finish symbol, so it has to be grinded or some tertiary process has to be done, so that is the finish symbol. And comes to this circle, so this circle is weld all around kind of a thing. And this flag symbol represents on-site welding. So in some places we will weld on the workshop and we will fix on the site, whereas if you are having a flag symbol, the welding has to be done on the site itself. So these are the different nomenclatures of the welding symbol, and these are the different welding symbols location. You can able to see if you are having a triangle at the bottom side, right? So the welding should be done at where the arrow ends, right? If you are having the arrow ends here and we are having the symbol like this, it has to be welded on this surface. If suppose this triangle on the above side, it has to be opposite side. If on both side, we have to weld on both the sides like this, the welding has to be done. So this will be represented in your engineering drawing itself, right? And these are the different welding symbols which represents butt welding, fillet welding, plug welding, okay, spot and seam welding. And here comes an example. So this will be given in your engineering drawing. You can able to see the weld symbol. So we are having a reference line and a arrow line and also the fillet kind of a line, and this is the additional information, that is GTW, it is gas tungsten arc welding. So how this will be welded, and also we are having a overall, so it's supposed to be welded on all the surfaces. You can able to see. So you are having a size, so that means 1 by 8, it is nothing but the type of a welding. Okay, so the size of a welding, it's about 1 by 8. So you can able to see the process is TIG, contour is flat, and finishing method is welding.